Hello, good afternoon. This is me, Avian from BMSIT-ISE. Today I am going to give a technical seminar on implementation of Weka for analysis of machine learning algorithms. At first, I'd like to thank Mrs. Veena N, Assistant Professor of Department of ISE, for her guidance and support. So, let us get into the seminar. So, the contents which we will be discussing today are Introduction to Weka tools, getting started with Weka, machine learning in Weka, classifiers in Weka, J48 tree-based classifier, decision stump algorithm, performance comparison, and then we go to application and test. So let us begin. So what is Weka? Weka is a tool that contains a collection of inbuilt machine learning algorithms that can be used for data mining purposes. So basically, Weka is a tool that has inbuilt machine learning algorithms that can be used in order for data mining tasks. The data mining tasks like pre-processing the data, classification, clustering, regression, and data visualization can be achieved through Weka. Talking about the history of Weka, Weka was developed by Wakaito Environment for Knowledge Analysis, developed by Wakaito University of New Zealand, and it is under the General Public GNU license. Now, let us see what is machine learning. Machine learning is a field of computer science that gives computer systems the ability to learn with data without being explicitly programmed. Rather than being programmed to do a thing, machine learning, by using machine learning, we can make computers decide themselves what to do. Like they'll be the deciding will be based on the data. So by pre-processing the data and applying various algorithms on the data, we predict what to do. Our program is able to predict what to do. So machine learning can be applied on various fields, including image recognition to from starting from the image recognition to making robots, making self-driving cars. There are a lot of implications of machine learning. So let us discuss about the features of Weka. The features of Weka are open source. It is open source software released by GPL GNU license, and it supports both the command line and the graphical user interface. The command and it can be used with Java also. Weka provides a set of Java tools, Java APIs, or Java classes that can be implemented in a program in order to use the features of Weka. And since it contains a lot of documentation, it will be easy for a new programmer or new data scientist to use Weka. So I'll discuss about the Weka environment. The Weka environment consists of three main components: the Explorer, the Experimenter, and the Knowledge Flow. Explorer is the first screen which you get and contains some normal things. Experimenter is a place where is a tool by using which you can perform experiment and compare between two or more algorithms. And knowledge flow is designing the pipeline for the problem. Like if you want to have a graphical visualization like bar graphs, then we use knowledge flow. So Weka has a lot of machine learning algorithm. That is great. It is one of the largest benefit of using Weka platform for machine learning. So like we have given the word lecture how to use the Weka tool. So as you can see, this is the Weka Explorer itself. So talking about the types of algorithms supported by the Weka, we can divide the types of algorithm into 7. The first one is the base type algorithm. Base algorithm is an algorithm for conditional probability. There are some algorithm like Naive base algorithm in the Weka in the Weka tool that can be used, that uses base algorithm as a reference for machine learning. So second is a function this estimate the function, for example linear regression. In this seminar we'll mainly discuss on the tree based algorithm. Like tree based algorithm form a decision tree. From based on that decision tree we decide what to do. So I'll discuss two algorithms on this. So the dataset which we'll be using today is called the Isis flower dataset. It was given by in 18 in the 19th century by a British botanician, and by seeing the pedal width and other factors of a flower, we decide the species of the Isis flower. So let us discuss the J48 algorithm. J48 algorithm is a simple C4.5 decision tree for classification. It creates a binary. So it creates a multi-layer binary tree. By this classification, we can classify the data. Once the tree is built, it can be applied to the tuples in the database, and result can like first we build the tree, then after generation of the tree, we apply that to a database, and that database by seeing that database, we can classify the data and predict the data. So this is, as you can see, this is a tree generated by a J48 algorithm. At each step, it will see the pedal width. If the pedal width is less than or equal to 6, then it is Iris setosa. Else, it will check if the pedal width is greater than 6. So, like this way, it will then classify the data, classify the flower into various groups depending upon the pedal width. So, it is the algorithm for J48. So the next algorithm which we'll discuss today is the decision stump algorithm. Decision stump algorithm is also a tree-based algorithm, but unlike a J48 algorithm, it is very simple, and it generates a single level tree. So this algorithm is faster than J48, but cannot it is faster than J48, but for the big problem it is not so accurate. So this decision stump can be used for purpose of bagging and boosting in data mining. So as you can see, for this there is only a level starting from the root node, and the graph is only of a single level. So in order to execute, these are the steps which will be taken in order to execute. In order to execute the machine learning algorithm, we have to follow this step. First, we have to open the Weka, go to the Explorer, then select a file, CSV file, which is a file which contains the data. Then we have to go to Classify tab, then expand the classified tree class, and then we have to choose these algorithms. So the parameters which we'll be evaluating is given here. The most important is the receiver operating characteristics, or the ROC curve. By seeing this value, we will decide which algorithm is better. It is a graphical approach for displaying the trade-off between the true positive rate TPR and the false positive rate FPR of a classifier. TPR is plotted around y-axis and FPR is plotted around x-axis. Performance of each classifier is represented as a point in by this way we can classify it. So for our data set, this is the result we will get. As you can see in this result, ROC area will be greater for the J48, so J48 will be the better one. So let us compare the TP rate and all. As you can see, I have given star for algorithm which perform better, and as you can see, J48 is much better than decision system in every parameter. So let us see the confusion matrix. Confusion matrix, if you see the confusion matrix, like for A, which is Iris setosa, it identified 49 as Iris setosa, but it identified 1 as Iris versicolor. So confusion matrix means how many of the total data was interpreted correctly. So experiment, we use the experimenter for we can see that the second one has the greater value, so J48 will be better than decision stump. So the conclusion is both J48 and decision storm performed well and has had a ROC area of more than 0.5, but since J48 has a bigger value than the decision storm, we conclude that J48 algorithm is better in performance than the decision storm algorithm. Okay, now I want to end this slide. Thank you.